A very good afternoon, everyone. Thank you for joining us for this webinar on the CoughVid app. Okay, and we have with us also a special guest, Ms. Lara Orlandic, all the way over from Switzerland, the EPFL lab. So I can see that some of you are still joining. So what we will do is we shall wait for 5 minutes and then we shall start the session. Okay. So in the meantime, please inform your friends who are also joining for the session. Tell them to join as soon as possible, and we shall start in another 5 minutes. All right. So see you soon, everyone. Thank you. A very good afternoon again to everyone. Thank you for your patience. We shall start the webinar right now. All right. So thank you once again for taking the time out of your busy Saturday schedule to join us for this webinar. We have with us Ms. Lara Orlandic, all the way over from EPFL, Switzerland. Ms. Lara, if you can say hello.
Yeah. Hi, everyone.
So we are joined by a mixed group of, a mixed group of in the audience. We have students who are taking part in the AI COVID Warrior Contest. We also have some parents, their parents may be joining in, and we also have some educators who might be their teachers joining in. So you can expect a lot of different questions from them as well.
Great.
All right. Yeah. So let me just introduce you to everyone, and then we shall start the fireside chat. So is my screen visible?
Yes.
Yeah, thank you. Okay, everyone, thank you once again. So thank you once again on behalf of AI School of India for joining us for this fireside chat. And I also thank you to those of you who have joined us for the AI COVID Warrior Contest. As part of the contest, we are conducting these fireside chats with experts in their field, especially the ones who are using AI to fight against COVID-19. And Ms. Lara Orlandic and her team are some of the people who are doing that, just that. And she will explain a little bit better when we, over the course of the webinar. All right. So a little bit about Ms. Lara. She is a Croatian American from Champaign, Illinois. She graduated from Georgia Tech in 2019, and she's currently finishing her master's in electrical engineering in EPFL, Switzerland. She will begin a PhD soon in October 2021 in EPFL itself, in the Embedded Systems Laboratory, where she's currently working as a research assistant. And she is also the co-creator of the CoughVid project in April 2020. So I'm sure many of you students who are taking part in the AI COVID Warrior Contest, you would have seen the presentations about the CoughVid app being used, as an application to in health screening in the fight against COVID-19. So this is the one of the co-creators behind the project, and we're really glad to have her with us. Okay. So everyone, just a few ground rules that we want to establish before we begin the fireside chat. I'm sure all of you will have questions as you're listening to Ms. Lara explain about her work and as she talks about her experiences and her discoveries and all that. So please feel free to use the chat box to put your answers over there. We have a team of moderators who are looking out for the questions in the chat box. Okay. And we have a special Q&A session also at the very end. So whatever questions that you have will be addressed by Ms. Lara at the very end of the session. All right. So we shall do that. So please feel free to use the chat box and put any questions that you have with regard to the fireside chat. Okay. So Ms. Lara, are you ready? We shall begin.
Yes, sounds great.
All right. All right. So let's begin the fireside chat. And the first question is.
Oh, sorry. I thought I was.
No problem. Yeah. So the first question is, what got you interested in this field, and or why did you become a scientist or researcher?
All right, so I think I was in middle school. So I grew up in the United States, and there you do like 5 years of elementary school and then 3 years of middle school. And I had this really good middle school teacher who sort of did little projects with us over the summer. So some of the students he saw that were really interested in science, he would kind of pull us aside and sort of like you're doing with the AI school. They would do these little projects on Saturdays or over the summer where we would do little experiments and also things that sort of hadn't been done before with kids so young. So that got me really interested, and he really taught me that science is something that can be used to solve any problem you can think of. It's really not just, making video games and robots and the fastest robot kind of thing. It can really be applied to anything out there. So you think of a problem in the world, think of climate change. Well, you can build refrigerators that use less energy, or you can build electric cars or things like that. So I really like that aspect of it, and that you can just learning these general tools that you can apply to any problem in the world.
Thank you very much. And the next question is, what is the importance of your research, especially with this CoughVid app?
Yeah, so my research in general with the embedded systems lab, we try to develop novel biosignal processing algorithms, which is basically where you take signals from the body that can be measured non-invasively. So you think of like the smartwatches or things that you can deploy onto a smartphone, and take the ensemble of those signals and sort of apply that to monitor people's daily health in real time. So instead of going to the doctor every time you're sick, so you can just maybe run your smartphone application or type some symptoms into your phone, and then it'll help you realize if you need to go to the doctor or not. So we've seen in the COVID-19 pandemic, this is really important if the doctor's offices get overloaded, or maybe it's not safe to go to the hospital because you can catch other diseases there. So with CoughVid especially, I think it was really exciting to develop this at a time when, these health-based problems were really all anybody was talking about and thinking about, because it was a really scary time, and it still is in many parts of the world. So yeah, no, like I said, it's really exciting to apply this research to the most pressing issues of our time, and try to develop solutions and more easier and more deployable ways of testing and screening for COVID-19.
Okay. So does this mean that we'll see a CoughVid app soon for smartwatches and all?
So so the CoughVid is designed to be a smartphone application because it uses the microphone. I think a lot of smartwatches don't have microphones yet, and it would be, I'm not sure how the sound quality would be compromised by that. But we haven't deployed the smartphone application yet, just because we want to make sure that the algorithms work really well before we deploy them. Because you can think, if you tell somebody that they're sick when they're not sick, then you cause them to panic. But if you tell somebody that they're not sick when they're sick, then they go out and they infect everyone else. So not the best. We've been doing a lot of testing and a lot of development, and we've been trying to get actual coughs from people with COVID-19, because all of ours are crowdsourced. And you can see, I'm going to talk a little bit about the drawbacks of crowdsourcing data. But so we want to make sure that they work really, really well before we deploy anything, because sometimes you can do more harm than good if you deploy something that doesn't work.
And it's something that you just launched last year, during the pandemic. So
we started in April 2020. I got the idea. Yeah, I can tell you more about that in my presentation.
Yep.
But I got some friends together, and then the project was picked up by the Embedded Systems Laboratory, and we continue working on it today.
All right. And the next one is, what was the most exciting discovery you made during your research?
Let's see. With my research, we do more like development and discoveries, but in terms of actual discoveries, when I was in my undergrad, so not my current research, but I did a different lab at Georgia Tech, we were putting like microphones on people's knees. So if you ever get that thing when you squat and your knees make a noise, like the kind of noise,
sound.
the cracking sound. So that's apparently worse in people with arthritis than people who are healthy. So we would put microphones on their knees to listen to it, and then use AI algorithms to sort of tell which people have arthritis and which ones don't. And just seeing the results the first time, seeing like, wow, this is something that really works. It sounds so weird, but it can really be used to monitor people's health in that strange way. So that was a really exciting discovery. And then with the CoughVid stuff, we haven't published our results yet on the COVID versus healthy coughs, but we continue working on that and improving them. So it's more exciting. It's gone from like not working super well to slowly getting better and better. So it wasn't like a aha moment of it works all at once. But I think you'll notice with AI that's kind of the trend of slowly getting better.
Yeah, as with any research, it takes time. It takes a lot of patience to get the
Exactly.
right results. Yeah. And I'll just pause for a moment. I see someone in the chat box. Dr. Nina Furia, if you're not able to hear us, I recommend that you join it again. Sometimes it does not work on the first time. You can just exit and join us again if you're not able to hear. I've asked my moderator to also just reply to you. Please. Okay. So the next question is. Are there any others who are doing similar research as yours? And how do you compare your results with them in the same area?
Yeah, so there have been a couple of teams. There was one team from Cambridge that did the same thing. They used deep learning models to diagnose the different cough sounds. So they used their own data set that they also crowdsourced during the COVID pandemic. So we did a sort of a similar paths, but then they're using deep learning. I don't know if you guys talked about the difference between machine learning and deep learning, but deep learning is sometimes like you feed in the raw data and then you get sort of a result at the end, but it's not that you don't really understand how it works as well. Whereas we're using classical machine learning. So we like run a bunch of math algorithms on the coughs, and then you can say, okay, well, this number is higher in COVID coughs than healthy coughs. So it's a bit more like you can learn a bit more about the coughs using machine learning than just classic deep learning. So that's the difference between that one. And then there was also a team at MIT that also used deep learning, and they used their own data set. And the main difference between our team and the rest of them is that we open sourced our data sets. So there's a big problem in AI right now where, well, I see it as a problem, but they're like everybody's collecting their own data sets and testing on their own data set. And when you have access to your own testing data, that might be a little problematic. And then it usually ends up being the biggest research labs and the most wealthy parts of the world have the most data, so they have the best algorithms. And I don't think that's fair. So I want it to be, I want the whole world to be able to have access to this data, and then whoever creates the best algorithm, like on their own merit, can benefit from it. So we have all of our data available online, so you can go to our website and download it and listen to all the coughs yourselves, and maybe even train your own algorithms. So that's something we really put a lot of effort into, which is why we don't have the results right away, like the COVID versus healthy classification, because we spent a lot of time on like perfecting the data set and making it available to everyone.
All right, thank you. So we just have one request from or one person from the audience. If
Sure.
maybe you could be a little bit slower.
Oh, sorry.
Yeah.
Sorry, I grew up in the United States and we talk fast.
Not so a problem. All right. Coming to the next question, what was the biggest challenge that you faced in your research, and how did you go about solving it?
Let's see. I think at the very beginning of the project, we were a bit confused about how to start, because when you look online, back at like the beginning of the pandemic, there weren't a lot of data sets available with coughs at all. Like there was the Google audio sets where you have, I'm going to talk about that in a second, but you have a bunch of cough sounds, but you don't know if they're healthy or sick. You don't know, there wasn't a lot of data that we could play with right away. So just getting the website running and trying to figure out how we were going to get coughs from people with COVID was a really big challenge. But thankfully, our university has a lot of good contacts with like journalists and media. So we did a lot of interviews very, very early in the pandemic. And thankfully, a lot of people were excited about the research because, it was the beginning of the pandemic and there were some researchers that had an idea. We didn't know if it would work or not. We still don't know exactly how well it works, but yeah, I think we had a lot of support from the media community. I did an interview with National Public Radio in the US. That was really exciting because I grew up listening to that, and hearing my own voice on it was really weird. But yeah, so I think that was the biggest challenge in this project.
Okay, thank you very much. And we see some questions also
Yeah.
asking, we'll have a look at them a little later, but yeah, they were asking like, how did you get about solving these problems? So, yeah, we'll have it. Um, the next question is, describe the day you saw your research published in the Nature journal, as we were mentioning when we were, during the practice run. So for every scientist, it's one of their greatest dreams to be published in one of the top journals in the world, and Nature is one of them. So how did you feel that particular day when your research was published?
Yes, just to put into context how exciting this is. So the way it works in research is you have an idea, you investigate it. If you get good results, then you publish a paper about it. And then other scientists read your paper, other people who are working on the same work, then they read your paper and then they point out some problems with it or something that you can fix. So then if you fix those things and they decide that your paper is good enough to share with the scientific community, then it gets published in a journal. And then there are different journals. Some are read by more people than others, and then that's how, you want your research to be published in the journal that the most people read, because that's the most exciting, it has the most impact, as we say. And then Nature is one of the top ones. So mine isn't published exactly in Nature, it's in Nature Scientific Data, which is still a Nature journal. But yeah, that was just crazy. I remember when my advisor told me we were going to try to get it published there, I thought, okay, it's a long shot, but maybe maybe it'll work. And then we got these like peer reviews, so the other scientists read my work, and then they had a lot of comments. Like I remember just pages and pages of comments on how to improve. Like we created an algorithm just to clean the database, so just to take out all of the sounds that weren't coughs out of the database. And they had lots and lots of comments on that. So you need to improve this, you need to make it better, you need to do that. So we spent, I think, between starting to write the paper and the paper getting published was almost a year. So just to give you the amount of time that it takes on all of this. And I remember I was in class when we finally got the news that it was accepted, and it was a Zoom class, of course, it was remote. So I just turned off my camera and did a little dance in my room because I was so happy.
That sounds amazing. I'm sure many students, or they can look forward to that.
Yeah,
Find out they can publish their own papers, especially the ones who want to become scientists.
for sure. Yeah. No idea is too crazy. Just if you have an idea, just go pursue it, and then maybe one day you'll end up in Switzerland doing research on it.
Don't give up. Yeah. All right. Before we go to your presentation, let's just take this one question. How do you think your research contributes in the battle against COVID-19? Because this is the main topic for the students in the AI COVID Warrior Contest. So they're coming up with their own ideas. The contest is getting over on the 31st of July. They're busy submitting the entries right now. So based on like that, that's the reason why we're conducting these webinars, getting ideas from scientists like you and from other experts as well. So how do you think your research will contribute in this battle against COVID-19?
All right. So I think that our research, the ultimate goal of it would be to create an application that can be used to quickly and non-invasively screen for COVID-19 using cough sounds. So instead of getting things, shoved up your nose, you just cough into your phone, which is first of all more comfortable. You can do it from home. So, maybe people who have reduced mobility, like older people, they don't have to go to a testing center. And then also people in areas of the world where testing isn't widely available. I know in some countries we're kind of spoiled. We have testing available everywhere, but that's not the case in a lot of the world. So that was really our main motivation. And even if the algorithms don't work, even if, we can't have a good distinction between COVID coughs and regular coughs, we can at least maybe learn about what COVID coughs sound like, and then kind of backtrack and realize, what does that mean about the underlying physiology of the disease? So what does it do to your lungs? What does it do to your throat? And all of that stuff. And then even beyond COVID, like we open source this data set full of lots and lots of information. So people who train cough classification algorithms in the future, they can use it for all sorts of different tasks. So maybe we won't be talking about COVID in a few years. We'll have some other, well, I hope we don't have another pandemic, but maybe, there's some other respiratory condition that you can possibly diagnose with cough sounds. And then they'll have this data set of coughs before that condition existed to be able to train it on as negative examples. So
you're saying you can use this as a model for other respiratory problems like tuberculosis,
Yeah.
typhoid. All right.
Yeah, hopefully. I think that yeah, you can have a bunch of coughs ready and readily available. And then just for us, even at the beginning of the project, like we wanted to figure out how to when you have an audio signal, how to just automatically find the cough inside of it and take that out. So that wasn't even like, it sounds stupid because like you listen to it and it's easy to tell where the cough is, but for AI algorithm, that's not always the case if you have lots of noise and lots of talking in the background. So there wasn't data available for us to do that. So researchers in the future, they can find our data sets and have a lot of data to play with, basically.
All right. Thank you. So before we go to the remaining questions, you do have a presentation to share with the students, and we have a game also as well, as you were telling yesterday. So shall we get into that? I'll stop sharing. You can share your screen
Great.
and maybe explain more about your work through the presentation.
Okay, you guys can see my screen?
Yes,
Okay,
we can see your screen.
thank you. All right, so yeah, thank you for the introduction and for the great questions. Like Barbie said, my name is Lara Orlandic. I'm a researcher at the Embedded Systems Laboratory of EPFL in Switzerland, and I'm really excited to tell you about CoughVid, which is an AI-based solution for COVID-19 screening using cough sounds. I'm sure you know a lot about that at this point. So I'm going to tell you a bit about the story behind CoughVid, so how we came up with this idea. So at the very beginning of the COVID pandemic, it was, I think, March 2020, I was isolating at home with my mom. So this is me, I'm the taller one because my mom is shorter than me now. And we were listening to a lot of the news about COVID-19, and my mom's a doctor, so she was learning a lot about what the different symptoms of COVID-19 were once our patients started getting it, because we didn't have, like, it didn't come to our town yet. And so in the meantime, one of our friends had all of the symptoms of COVID. She had a cough, she had a fever, she couldn't get out of bed. And this was before testing was available everywhere. It was either you had a really bad, really severe COVID and you went to the hospital and then they would test you, or you would sit at home and wait it out. So she called my mom to see what she should do. So I asked my mom, what do you think? What do you think it was? Do you think it's COVID or not? And my mom said, yeah, I think it is, because you can hear a lot of the patients who have COVID, they have this really distinctive dry cough. And I said, dry cough, what is that? What's the difference between a dry and a wet cough? I didn't know any of this. And so that got me thinking, if people can tell the difference between cough sounds, then I think machine learning algorithms and computers should be able to as well. So if we leverage the power of signal processing, machine learning, and get lots of data about what different coughs sound like, and especially coronavirus coughs, then potentially we can use this to provide rapid screening technology. So then I called up a lot of my friends. I was in the US at the time, then my friends were in Switzerland, Israel, all over the world. And I said, hey guys, I have this idea. What do you think? We should enter a hackathon to sort of develop it. And they all said, yeah, that's a great idea. And then we all put our minds together and created CoughVid. So I'm going to talk a little bit about the motivation and background, just to give some statistics. So we know that widespread COVID testing is essential for contact tracing. So if one of you gets sick and you're in contact with your friend, then it's really important to tell your friend, hey, you've been exposed to somebody with COVID. You should stay at home to not infect anyone else. Then one of the most common symptoms of the disease is a dry cough, which occurs in about 70% of cases. And then we know automatic cough sound classification. So being able to listen to a cough sound and the computer telling you whether or not you have a certain disease. It's been successfully used to diagnose pertussis, which is whooping cough, asthma, and pneumonia. And then it's a rapid, scalable, and inexpensive diagnostic tool, so it can be deployed on something like a smartphone. So just with your phone, you can cough into it and it tells you if you're sick or not, which is much better than having to go to the doctor's office to listen to that. So the first goal would be to train machine learning models for COVID-19 screening based on cough sounds. So the idea behind CoughVid is that a person coughs into their elbow with their phone at arm's length away, and then the cough data gets uploaded to a server, which then performs signal processing and machine learning, and goes back through the cloud to create a diagnosis. And then the machine learning algorithm, puts whether the person's sick or not. And then they get a notification on their phone saying, yes, you have COVID, you need to self-isolate, or don't worry, you just have the sniffles. So in order to do this, you need lots and lots of data available for the machine learning algorithm to learn from. So let's look at the data sets that are publicly available. Like I was saying at the beginning of the project, we didn't find a whole lot. There's Google Audio Set, which has about 900 coughs, which is actually a lot, but they're not labeled, so you don't know if somebody's coughing because they're sick or they're coughing because they have they have pneumonia, or they're just clearing their throat. And it's pre-COVID, so there are no COVID coughs on there. Then there's the IIT data set where they had 110 coughs from 30 subjects who were in the hospital. So they were actually diagnosed with certain respiratory conditions, but this is also pre-COVID, and 30 subjects isn't that much. Then there's the No Coco Da. This one's kind of interesting. They took media interviews from COVID positive patients, and then they segmented, or they cut out the 73 coughs from 10 subjects, which is really interesting because the people are COVID positive, but it's only 10 subjects, so that's not enough for machine learning algorithms to generalize to the global population. So another goal would be to provide a diverse and labeled cough sound data set for a variety of different cough classification tasks. So in terms of the data collection, we had a website. We had a web server that was the CoughVid website that was available from April to December of 2020. Then it's really simple. So all you had to do was click record, and it would record 10 seconds of a person coughing. Then the users could input metadata, which is basically whether they had been diagnosed with COVID-19 or not, their age and their gender. Then this is all fully anonymous, and the GPS, we took GPS information as well, just to see if the coughs were coming from countries where COVID was prevalent at the time. So the GPS is blurred to 11 kilometers, so it's impossible to trace somebody from their cough sound. Then we have safe config instructions, just to make sure that people don't spread the pandemic just by using our website. That would be very bad. So we told people to go inside, get away from everybody, and then cough into their elbow. So here's a map of the world. So most of our data recordings came from April and May 2020, because that's when we got the most attention from journalists. And so this is the map of the world, color-coded by the number of COVID cases per 1 million population. And then these green dots are the COVID positive data we got, and the blue ones are symptomatic. So you can see most of our data came from Europe and the United States, where the disease was really, really going crazy at the time. And most of them come from countries where it was prevalent. You can see back in India, it wasn't that bad at the time, but we need to get some more data perhaps with the new variants. Then if we look at an overview of our data set, we have over 25,000 crowdsourced recordings, which is really exciting. And over 1,000 of them claim to be COVID positive, so way larger than all of the other public data sets that we had. Then the participants labeled their age, their gender, and their COVID-19 status. So whether they had just been diagnosed as positive, whether they had symptoms but they didn't have a COVID test, or whether they were healthy. So now we're going to play a game. So I'm going to play 4 of the sounds that we received through our website, and then you're going to guess the labels. So whether they're COVID-19 positive, symptomatic, healthy, or not a cough. So are you guys ready? We're going to conduct a poll, and then you can...
I'll just begin with poll, all right?
Okay,
so
great.
Everyone, if you can just have a look at your chat box also, we'll just begin a poll. So we have different, as Ms. Lara said, we have different, cough sound samples. All right, so 4 cough sound samples. I'm going to start the first poll and have it ready. So she's going to play the sound, and then just listen to it, and then you click wherever whichever sound you feel is that it belongs to. Okay. So okay. I'm starting the poll now.
Actually, we're gonna play each sound twice, just so that people hear all of them. If that's okay.
All right.
Okay.
So just I'm beginning. I'm publishing the poll right now.
Okay. Great. Okay, so I'm gonna go. Okay, that's the first sound. Let's play it again. Okay, now we're gonna play the second one.
I think we'll just wait for 1 minute. And
Okay.
some
Oh yeah.
people they're still answering.
Okay. Yeah. I was thinking we could play them all first and then then vote. But yes. Okay. You can vote on the first one first. Do you think it's COVID, symptomatic, or healthy?
Okay, everyone, we're going to go to this next sample right now. So I'll end this first poll. Okay.
Okay. So we think it's COVID
So
positive.
I'll just take a screenshot of the and keep it ready. Hold on.
Okay. Are we ready to go to the second one?
Just give me a second.
Yeah, no worries.
Screenshot. Yeah. Okay, everyone. So we're going for the second poll now. Okay. We're starting in 3, 2, 1. Ready, ma'am? Ready, Ms. Lara? We'll play this now.
Yep.
Yeah.
Okay, let's play it again.
Okay, just wait for the audience to start.
Sure.
Entering all. Okay.
Ooh, I see the numbers changing a lot. The bars are dancing up and down.
Yeah, it's still it's still very undecided compared to the first one.
Yeah. It's okay. It's hard work. It's not obvious.
Right. So let me just take a copy of this and keep it ready. Okay, everyone, thank you for your answers. We'll go to the third cough sample now.
Okay. Here's the third sample.
Ready, Ms. Lara?
Yep. Okay, let's play it again. Okay, what do you guys think?
Yeah, similarly, the bars are also dancing over here.
Okay, I'm seeing a lot of COVID positive, a lot of symptomatic. This one seems a little more decisive.
Yeah. Okay, I think everyone must have finished. Okay, thank you everyone once again. Let's go to the final one.
Okay.
Are you ready, Ms. Lara? We'll play this out.
Yep. One more time. Okay, what do you guys think that one was? Yeah.
We have a fight between two bars. That'll be another call.
Great. Yeah, this one's more decisive.
Okay. All right. So thank you, everyone. I'm going to end the poll right now. So let's have a look at I've just taken the copy of your answers. Okay, Ms. Lara, you can show them the results.
Okay, so the first one was actually symptomatic. Do we want to play them again just so they listen to which one was which?
Sure,
okay, so let's play this one again, the first one, which was symptomatic. Okay, so that one, the person said they had symptoms, but they didn't go get tested, so we don't know if they had COVID or not. Then the second one was healthy. Let's play that one. Yeah, so you can see they're kind of clearing their throat. It's not really that bad. It doesn't have that. It's sort of a voluntary cough instead of an involuntary cough. Then the third one, they labeled as COVID positive. Let's play that one. Yeah, so that one you can tell there's something wrong there. They're not forcing themselves to cough. There's actually some kind of respiratory condition going on. And then the last one, you guessed right, was not a cough. So that one, that person's just saying cough, cough. And unfortunately, the problem with crowdsourcing is that we get a lot of this data. So sometimes when you release data collection software to the entire internet, you of course get a lot of weird things. So you have a lot of silence, you have a lot of TV noises. Sometimes somebody uploaded sounds of them meowing into the phone. So yeah, so one of our biggest challenges was just removing all of that so that our machine learning models can only learn from the good data.
Okay.
So yeah, thank you for playing. Did anybody get all of them right?
Let me have a look at the results. So for the first one, many of them, 47% for COVID-19 positive.
Okay.
And for the second cough, it's about 29% for symptomatic.
Okay.
And for the third one, it's 33% for healthy.
Okay.
And for the last one, it's 79% for not a cough.
Okay. At least the last one we agree on. Well, it's not an easy task. I think if you found it hard, that's because you didn't have a lot of data to listen to. If you're like me, you've listened to hundreds of these, you start to pick up on patterns. And then the same thing with machine learning models. So they need lots and lots of data in order to be able to find patterns between the COVID coughs and the healthy coughs. So I'm going to talk about this a bit now with our machine learning model development, so how we actually train our models to distinguish between COVID and healthy coughs. So first we separate the data into two classes. So it can be COVID versus healthy, it can be wet cough versus dry cough, depending on what you're looking at. Then we take some of the data and we set it aside just to be able to test our models later. Then we do cough signal processing, which basically means we remove any noise from the signals, and we do segmentation, meaning we cut the part of the recording that has a cough in it, and we remove all of the silence and all of the breathing noises and other stuff. Then we extract audio features, which basically means we run a bunch of math algorithms to see what are common features of the signal that we can sort of use to distinguish COVID versus healthy. Then we train and optimize machine learning models to be able to tell whether a cough is COVID or healthy based on the feature data. And then finally, once we have a model that we trained and optimized, we use this hidden test set that it wasn't used for training in order to evaluate how well our model performed. So that's basically our development pipeline. And then an additional layer that we had of sort of validation of the data was that since we're not doctors and we couldn't tell if a cough sounded actually healthy or not, I mean, we can sort of get an intuition, but there's not, we didn't go to medical school to learn these things. We were fortunate enough to have 4 doctors label over 2,000 recordings. And then we have a lot of information from each doctor. They labeled whether the cough was wet or dry, whether there was wheezing, dyspnea, which means shortness of breath, like people kind of gasping for air, choking, etc. Then there was the diagnosis of the cough, whether it was a respiratory infection or COVID. Then the cough severity, whether it was mild, severe, or a pseudo cough, which is where you're faking a cough. Then if we look at all of the coughs that the experts labeled as COVID-19 positive, the majority were labeled as dry coughs, which makes sense. Usually this is a symptom of COVID. There's nothing specific, meaning that they didn't have any wheezing or shortness of breath or those things. And most of them were mild. So one really exciting thing about the CoughVid data is that it's open to the whole research community and to you guys as well. So I'm going to share a link, and if you want, you can download the whole data set and you can listen to lots and lots of these cough sounds and see if you can find the patterns in COVID versus healthy coughs. And then, yeah, I'll share this link. We have over almost 4,000 downloads, so you can see lots of people are already doing this and already training their own models. So that's really exciting for us as researchers to sort of develop something that so many people are using. And yeah, if you want to use this as part of your Warrior contest, feel free. If you have any questions or ideas for me, I'd be happy to hear that. And yeah, so there's the link to our data set. Then there's the links to, we open sourced some code for pre-processing. So basically taking the noise out of the coughs and segmenting the coughs from the non-coughs. Then we have the CoughVid publication in Nature that we were talking about. It just goes into the details about the data set and how to use the data set. It's a bit technical, but you guys are smart, I'm sure you can figure it out. And then more information about CoughVid from our website. And yeah, there's my email address, the CoughVid email address, but it redirects to mine. So feel free to email that and let me know if you have any questions or just ask here now in the chat. And yeah, I wanted to thank our sponsors for funding this project and taking what came up as my daydreams during a pandemic into a global research initiative. So I'm really thankful for that. And yeah, let me know if you have any questions.
So we have a lot of questions actually from the audience.
Oof, I wasn't looking at the chat.
Not a problem. We've collected them all, and we'll ask them in just some time.
Great.
So we'll just finish off with two more questions from the for the interview.
Sure.
So the first one is, what was the coolest thing that you encountered in your research?
Oh, the coolest thing. Let's see. I think we got contacted by the World Health Organization at some point because they were making a COVID app, because they're right in Geneva. We're in Lausanne, Switzerland, and Geneva is like 45 minutes away. So they contacted our team and they asked like, hey, do you have an app that's ready? Can we integrate it into our COVID app? And then a lot of like local governments and things have been reaching out to us to help before testing was widely available, to see if we could like make the app available and be able to see to locate where people with COVID symptoms were located. But unfortunately at the time we didn't have anything ready, and we still don't have something that's so conclusively that works so well that we can deploy at a large scale. But it was just really exciting to get that attention from such a global organization.
True. And you also follow, you follow closely with the research. I think the WHO says that 67.7% of the COVID-19 patients exhibit a dry cough. Mm-hmm. So your research is also very, very similar to what they found.
Yeah, exactly. So when we sent the coughs to the doctors, I think ours were a little higher. So the 87% of the coughs were labeled as dry. And so we don't have any like PCR confirmed. Well, we're in the process of getting PCR confirmed COVID coughs from a hospital in Spain. So to be able to say like conclusively which one is COVID and which one isn't, because when you train on crowdsourced data, you get a lot of noise. But so we didn't actually test people with COVID. That was really difficult to do at the time because any research related to COVID has to be like very heavily monitored, so you don't create another outbreak. But it's been pretty consistent with what the experts are saying.
Okay, thank you. We have a fun question right now.
Sure.
So can you tell us what you like to do when you're not working on research?
Oh yeah, so I really like hiking. This is a map of the Swiss Alps right behind me. So I like to go into the mountains and just relax and get some fresh air and exercise. I also really like to cook. So I try various different types of recipes. I try some Indian food, but I'm sure it's disgusting compared to what the amazing specialties you guys have. So yeah, lots of different things.
Thank you very much. And we'll finish off with one more, the last question. Can you share any words of advice with the students who are attending over here, who are planning on becoming scientists or researchers like you?
Mm-hmm. Yeah, I'd say, I think in order to get to where I am as an engineer, like you have to go through lots and lots of math and science courses that sometimes, actually very often, you're going to ask yourself, when am I ever going to need to know this? Like it sounds really abstract, like you get these really hard math problems and you think, oh, when am I ever going to need this in my life? And then I'm just saying, just wait until college, just wait until graduate school. You will see when that's going to be important, because I mean, it seems abstract and weird, and some math guy created postulated these theorems 100 years ago, but actually they can be used to fight global pandemics and create solutions to climate change. And they have really exciting applicable things. So I think just if you ever tell yourself like it's too hard or it's too abstract, like just hang in a little bit longer, and I think you'll see the rewards once you actually start working, once you start developing solutions, and then just keep if you have an idea like mine, just make sure to pursue it, talk to people, talk to your friends and doctors who work in other professions, and then try to like create solutions to problems, because no idea is too weird to be explored through research.
Thank you very much for that.
Yep.
So this hereby ends the fireside chat, and we shall now enter the time of Q&A. So what I shall do is just before that, we have a bit of a fun activity to do. Ms. Lara, if you can just stop sharing your screen, please. Yeah. So everyone, what we're going to do right now is we're going to play a little bit of an AI game. So just let me share my screen with you. Give me a couple of seconds. Yeah. So what we're going to do now is I'm going to share my screen with you, and I'm also going to share a link. Okay, we're going to try a fun AI game, which will ask you about a review about this particular webinar that we're doing right now. Okay, so you can use it either on your laptop or you can use it on your phone. Okay, so what I'm going to do is I'm going to just share my screen with, I'm going to share a link with you now, and everyone in the audience can just give it a try. Okay. So I request you to please do it in your free time. What it'll do is it'll just, this particular app, what it'll do is it follows a machine learning model, okay, and it'll try to create the review on its own. Okay, you don't need to do anything much, just provide the data for this AI to do that, and it'll use the machine learning models to create a review on its own. Okay, so now, as we mentioned earlier, we shall enter into the time of Q&A. And we have got a lot of questions from the students. So let's just take those up. So we have a question from, okay, we have a question from Anshu Mahendra. Ms. Lara, are you ready?
Mm-hmm.
All right. So many people don't have symptoms at all, nor do they always have cough as a symptom. So how will this particular app help?
Exactly. So that's one of the main limitations of our research, is that if you don't have any symptoms, then we can't really help. So one different thing, so there's two types of coughs. There's voluntary coughs and there's involuntary coughs. So once you can either force yourself to cough, and then that's a different neurological mechanism, because it goes through your brain is making yourself cough. And then there's an involuntary cough, which goes through the spinal cord, and it's just like your body needs to get something out of it, so it coughs. So there's one theory that even with voluntary coughs, like if you force someone to cough, then you can diagnose the diseases even if they don't have symptoms. But then, if you're only looking at diagnosing the voluntary coughs, then we can only be up to 70% accurate, because that's the percentage of people who have coughs. So that's one of the limitations of our study, but it's still, I mean, it's possible that even if people don't have cough as a symptom, that if you force them to cough, then there's some, you still get all of the sounds that are produced in their respiratory tract, and you can potentially hear whether they have COVID or not.
All right, thank you very much for answering that.
Yep.
So we have a question from Arika. So what programming language did you use to create this particular CoughVid application?
Yeah, well, so there's three different things. We have the website, which we created in, I think it was some combination of HTML and things. I didn't make the website, it was my colleague. So that was the one to collect the coughs, to collect all the data. Then we have all the machine learning code, which I do in Python. So Python is my favorite language, not to bias anyone. There's many good languages out there, but Python is my favorite. And then the app itself. So we do have an Android team on the side that's creating an app in case the algorithms work one day and we want to deploy the app to the global population, and that's being made in Java.
All right. So mainly it's Python and JavaScript, apart from the website.
Yeah.
All right. Okay. So we have a we have a very interesting question.
Okay.
Does a patient coughing within a radius of 11 kilometers can be detected with this app?
Oh, so when I said 11 kilometers, I meant like so every time somebody uploads a cough, they upload it with their GPS information. So like they upload like their exact GPS coordinates, and then we like remove some of the precision. So it's like instead of saying this person was exactly in this location when they coughed, that's kind of a privacy concern. So when we published the data set, we removed some of the decimal places on the GPS location. So it was like an 11-kilometer radius. I didn't mean that like if you cough 11 kilometers away, we can hear it, because I don't think that's possible. That would be really cool, but
Maybe with drones, or who knows? We can
yeah,
collect
you
data
can
with
have a
drones
drone.
later. Uh, One more question. Oh, sorry. Oh, one question from
Yeah,
Ms. Arya. She's been asking this from the very beginning.
sure.
She wants to ask you, how did your journey start? I mean, how did your journey as a maybe as research? How did you, you know, go about this? How did it start?
Oh man, that's a good question. I don't know. Let's see. So I had that really good science teacher in middle school, and then I took more and more science classes in high school. I really liked them. I was never really the best in my classes. So yeah, don't let that discourage you either. If you're not like the #1 math champion in India, you can still do really cool things and have great ideas. So yeah, so then I did really well in my classes. I got into Georgia Tech, which was a pretty good school in engineering in the US. And then I started out in biomedical engineering because I really wanted to make technologies that help people. But then I had this professor who kind of took me under his wing, and he said, no, you should switch to electrical. It's more it's more applicable. And yeah, I really don't regret that. So I did electrical engineering in my undergrad. And then I found out about this research lab here in Switzerland who does exactly the kind of research that I'm interested in, with using non-invasive biosignal processing technology to be able to monitor chronic health conditions from home. So I applied there and I got in for the master's, and it worked out really well because I really like hiking. So I'm in the Alps and I really don't regret that. So yeah, I just said, if you want to follow my footsteps, just work really hard on your math and science classes. It's okay if you're not the best, but still put a lot of effort into it, ask questions, do the best you can, and just kind of brainstorm what problems you want to see solved in the next 10, 20 years, because in that time, you're going to be one of the people solving them.
Thank you, thank you. I think we have a question from one of our very young members of the audience. Do you
Yay.
like being a scientist?
I do. It's really exciting. I mean, every once in a while you have those hard times where you work really hard on something, in the end it doesn't work. But I mean, that's every profession. I think these are highs and lows. But the exciting thing about being a scientist is that, I mean, especially with electrical engineering, everywhere around the world we have technology that plugs into a wall. Like you can really travel anywhere, do anything you want. The possibilities are endless. And yeah, and then I really like to, brainstorm solutions to global problems and think how we can use AI and signal processing to solve sort of the issues that people have day to day. And yeah, it's nice because you can work remotely too. So I know I had some friends, I'm not supposed to, I don't want to name names, but when we were all working remotely, they would they would like rent a house in the mountains with really good Wi-Fi. So they would work during the day and then hike during the afternoon. So yeah, you can really do it anywhere. Yeah, I've heard of people doing this on beaches too. So it's nice to be able to work remotely and yeah, enjoy life as
One,
well as work.
I think one more question from the same audience member. Is
Yeah.
your job hard?
Yeah, it depends what you mean by hard. Yeah, you spend a lot of time in front of a computer. You spend a lot of time because you work on problems that nobody has solved before, nobody's tried before. There's no YouTube tutorial. There's no person on Stack Overflow who has the exact same problem that you've had. So that's hard in a sense of you have to figure out how to do things yourself. I know sometimes in your math classes, you have the set of problems you have to do, and then you just solve the problems and you're done. But you have to figure out what the problem is sometimes. So that's hard, but it's also rewarding too, because once you propose a solution yourself, and then other scientists say, wow, that's a good solution. I remember one of my proudest moments was when I presented at a conference. This was a different research field. It was about like using AI to tell different for heart conditions, like being able to analyze an ECG signal and figure out if somebody has heart conditions from that. And there was like the mother of this research field, like the woman whose ideas like revolutionized the technology, and she was sitting in the conference, and after my presentation she's like, oh, good job, that's really interesting work, and I almost just melted. That's it's hard, but it's rewarding is my answer.
Thank you. Kanishka is asking, was becoming a scientist your passion from your young age? I mean, were you passionate about becoming a scientist from very young?
When did I decide to become a scientist? That's a good question. I wanted to be a veterinarian as a kid. I really liked cats, so I wanted to help cats, I guess. But yeah, I guess everything I was interested in kind of revolved around science. But I really like writing as well. I was the editor of my high school newspaper, and it turns out that you need both. Like, if you want to be a good scientist, you can't just be really, really good at math and science. You also have to be able to know how to present to people, how to write articles, write papers. So even if you're not like super math and sciencey and really like program in your free time, or you have other hobbies, like you can very easily combine those into that. So I was kind of interested in a lot of things, but I always knew I would do some sort of math and science career because there's endless possibilities and endless career options. So it's a good place to be.
Thank you. We'll just take a couple more before we come to the end.
Sure.
So how many months did you take to develop this app? One question from Minish.
Let's see. So just to make the website, I think my friend put it together in about 2 to 3 days. So that was really quick. So that was when we started collecting data. And then the AI algorithm. So we've been working on that continuously ever since April 2020. So just working on developing the technology that can tell what's a COVID cough, what's a non-COVID cough, because that kind of happens in parallel with collecting data. Like the better data you collect, the better your algorithms are going to work. So that's been going on since, April 2020. So about a year and a half now. So it's not it takes a while, and then some things are a lot easier. Like you can make AI algorithms that tell cat photos from dog photos, and that can be done in 20 minutes, but that's just the nature of our problem, is it's a little bit harder to tell.
Thank you. And let's think. Okay, yeah. Is this your very first project, and what is next after CoughVid?
It is not my first project. In my undergrad, I worked on a lot of those, that project with the joint sounds I told you about, where the people would squat and we would put microphones on their knees. So that was one of my first projects. Then, so I kept being interested in biosignal processing, so the joint sounds, the heart electrical activity, and then cough sounds are sort of the new thing that I'm working on. And so what's next is I'm really excited to put all of those together. So not just looking at the sound of a person's cough if they have COVID, maybe you combine that with their electrocardiogram, which is the electrical activity of their heart. Then you combine that with blood pressure and skin impedance. So some of those smartwatches, they actually have sensors to tell how much you sweat. And that tells a lot about, first of all, how if you're sick or not, and also your emotions, because when you get excited, you start to sweat more. So I want to make like a really multimodal system, as we say, that analyzes all these sorts of biosignals together to get a global idea of a person's health state.
Thank you. And we have one question from an educator.
Yep.
What was that question? What is the accuracy of prediction, and how are you improving false positives?
Yeah, so right now so anytime you ask about the accuracy, you also have to ask on what you're testing on, because you have many different research teams around the world that are only testing on their data, or they're testing on crowdsourced data like we have, or maybe they have PCR confirmed data. Then I remember there was an MIT team that said they had 100% asymptomatic detection rate, which is very, I mean, I hope that it works that well. That's that would be great for humanity if it did, but I'm kind of curious as to how they gathered that data. So right now on our just the crowdsourced recordings, we have I'm trying to remember the last numbers we got. I think we had let's see, I think it was like 70% sensitivity, which is the one of like being able to detect. So there's one that's like false positives versus like how many people you say are actually sick that you detect accurately, and how many like you out of the whole population. Yeah, so how many you detect accurately and how many you detect accurately versus the false positives, because you can just say like everyone's sick and then you detect 100% of cases, or you can say no one's sick and you have no false positives. So I think we have, yeah, our false positive rate was something not too high, but then the sensitivity was also lower. So I don't have the exact numbers in mind because I've run like thousands of iterations of this, and we're still collecting data with this team in Spain to get actual PCR confirmed information. So I don't have the exact numbers for you, but it's climbing. We're working on it.
Okay, thank you. I'm just going to take two questions, put them together.
Yeah.
So Aditi is asking, how many hours do you spend coding? And
Mm-hmm.
Nimesh is also asking, how many hours do you work in a day? It's very general questions.
Yeah. Oh, it really depends. So I'm also taking classes on the side. I don't just code all the time because I have to finish my master's. So I'd say I spend like maybe 3-4 hours on classes, and then code for 2 or 3, and then sometimes I have to, yeah, sometimes I don't have a lot of classwork. Maybe we have a break in that, and then I code for, I don't know, maybe 5, 6. There's also coding, and then there's debugging code, which is another big. You only spend so much time writing, but then you test it and it doesn't work, so you have to go through and debug it. So I'd say coding plus debugging, maybe 5-6 hours, but it depends. I like to take lots of breaks. I'm not the kind of person who can just lock themselves in a basement and come up with great things after working for 36 hours. Like I need to take a little break, maybe cook a little, code again, and then go outside, go for a walk, and then code again. So overall, that whole process maybe takes 8-9 hours a day, but it depends. Like if we have some deadline, then I'll work more, or if we don't have anything, then I'll work less. So it depends a lot. Sorry for not answering the question.
Not a problem. I hope that that gave an answer, that gave an idea to everyone that you don't always have to spend
No.
all your time coding to get things done.
Yeah, exactly. I think there's really, in computer science, there's this kind of hackathon culture of like you lock yourselves in a room for 3 days and then you come up with brilliant solutions. I can't work like that. I've been to 2 hackathons. Well, one of them was online, which was better. The other one was in person, and I just hated the whole thing. So there's, even if you're not like that, you can still be a good engineer.
True, true. So we'll finish off this fireside chat with one more question. But once again, I'll just club it together. It's asked by Ms. Aditi and by Ms. Mona Lisa. So basically, they're asking, who is your role model and who was your inspiration? So
Ooh.
who got you into becoming a scientist?
Oh, that's a good question. I'd say, well, my parents are both involved in science professions. My mom's a doctor, my dad's a software engineer, so I kind of saw those kinds of things growing up. Let's see, in terms of like famous people or scientists, so there's that woman who really pioneered biosignal processing research, Rosalind Picard at MIT, who I got to meet at a conference. So I think her work is really exciting, and also, there haven't been as many women as men in engineering throughout the years, and I think like her work is really good to show like this is anyone in the world can do this, no matter what your gender, ethnicity, anything. Like people have skills to bring to the table regardless of those demographics. And then I remember when I was in high school, I read Richard Feynman's biography. He's a famous physicist, and this might be, I think maybe in a few years when you learn a bit more physics, you can appreciate it a little bit more. I mean, even if you don't, I think you can read the biography, and it's pretty inspiring just how this man, like, he turns everything into a question, and he's curious about everything, and like I remember he would worked in a biology lab for a summer just to learn more about biology, and then from that day on, he learned how to open his toothpaste with only one hand, because he would have to like pipette something in one hand and then open vials in the other. So he's like, I learned how to open toothpaste. Anyway, that's kind of a cute thing. But yeah, Richard Feynman's biography really gets you excited about science and really makes you think about the world is how it is.
So there you have it, children. So you can also check out Richard Feynman if you want to know more who got interested into this. Okay, so we'll just take one more and close it off. So what programming languages do you recommend for young children to learn?
Let's see. My first programming language was MATLAB, but I wouldn't recommend that. I think I would go with Python because it's free, it's a little bit more intuitive. You can open it in something like Jupyter Notebook, and it's like you can see the plots in real time, and really, it's a nice interface to be able to play with it. Like the code is in different colors and stuff like that. So I think it's a lot easier. And then Python is the same thing. You can do anything with it. Like you can make websites, you can do AI algorithms, you can do data visualization. I love doing data visualization, like making pretty graphs is super fun. So I'd say start with Python, but I mean, you ask, it's very subjective. Like you ask somebody who does a lot of Java, they'll tell you learn Java, and it's I'm very biased.
Okay, so I think that's we've come to the close of our webinar. So thank you very much, Ms. Lara, for joining us for this.
No problem. Thank you for inviting me, and I hope it was exciting. Yeah, if it's interesting, feel free to email me if you have any more questions or you think of something tomorrow or the day after.
We'll do that. I will share your email ID with the students, and we'll share it with the audience members, and they can get in touch with you. And especially want to thank the audience members for joining us, for taking time out of their Saturdays, and I hope that this session has been very inspirational and it's been helpful to you preparing for the contest as well. And if you have any further queries, as earlier, we will share Ms. Lara's email ID, and you can get in touch with her. Okay. And just one more small request, dear audience members, we're just putting up that app again, the link to that AI app again. So please feel free to provide your reviews over there by clicking on that link. So just putting it there in the chat box. All right. And yes, we'll do that. Yes, join. We'll share all the links in the WhatsApp group as well. Okay. So thank you once again for joining us. Thank you, Ms. Lara. And we wish you all the best for your research, especially for your PhD. Thank you for joining us. And maybe we also hope to see you once again soon in another session with the children as well.
Definitely. Yeah. Good luck with your contest. And I hope to see you one day at conferences and at the research institutes around the world.
All right. So we're getting a lot of thank you messages from everyone also. So thank you once again, Ms. Lara. Thank you, children. Thank you, parents. And thank you, educators, for joining us for this session. Have a lovely evening. Stay home, stay safe, and stay healthy until we finally get out of this pandemic situation. Okay. Take care. Thank you, Ms. Lara.
Thank you. Bye-bye.
Bye.